Hey everyone, this is a quick video on how to take an equation of a parabola in vertex form and then apply the transformations that happened in vertex form to the table of values for the parent function. So when I start these questions off, the first thing I would do is I would look at your equation and I develop the transformations. So the first thing I look at is I look inside the brackets and I see that I have x minus 2. The transformation is going to happen such that I'm going to move the parabola to the right by 2 in this example, because we have a negative 2 here, and as we move it out, it becomes positive 2 here. And that would be my transformations to the x values of my table of values. To the y values, I know there's two things happening. I'm moving my y down 7. And I'm also transforming the y step pattern, or I'm stretching it out by a factor of 5. So that's how I use that. So I take the negative 7 here, the 5, and it goes on, and those are the transformations that happen to the y values. And then inside the brackets, those are the transformations that happen to the x values. So that's my setup. The next thing is I'm transforming the parent function of the table of values. So I know my table of values for the parent function looks something like this. And then a negative 3 squared is 9. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. So now I'm going to take my transformations and apply them to my values. I'm going to add 2, 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 because that's the transformation I'm doing. Negative 1, 0, 1, 2, 3, 4, 5. That was the easy side. Now for the other side. I know I'm going to do that to my parent function. I'm applying the transformations to the y values of my parent function. So I do this over and over again. This is going to take a little bit of work because I'm multiplying by 5. I should have picked a different example when I did this, but oh well. I might need to do a bit of calculator work to do this. I can do some of these in my head as I'm looking at. Okay, so 5 times 9 is 45. Why did I change to 5s here? That's a silly mistake there. Sorry about that. 5 times 9 is 45. 45 minus 7 would be 38. 5 times 4 is 20. Minus 7 would be 13. 5 times 1 is 5. Minus 7 would be negative 2. 5 times 0 is 0. Minus 7 is negative 7. 5 times 1 is 5. Minus 2, and you can see I'm now reflecting. 5 times 4 is 20. Minus 7 is 13. 5 times 9 is 45, minus 7 is 38. I do a quick double check at this point, and I look to see where is my vertex, and I know my vertex is at 0, 0, so I look here real quick, and I make sure at positive 2, 5 times 0 minus 7 is negative 7, there we go, fixed. And I caught that mistake because I looked up here, and I knew my vertex would be at positive 2, negative 7, and positive 2, negative 7 is where that is. That's how I do it. I now would take these values and I'd graph them. So I'd know that that's probably out of the bounds of my graph. I know it's 0, 13. I got a y-intercept, so that's where I quickly drop a dot at 0, 13. I know my next point is at 1, negative 2. So 1, negative 2 would be my next point. Then at 2, negative 7, 6, 7, 2, negative 7, and then I mirror my way back up. And there is my parabola right there. I'll try to draw it nicely, but it's going to look a little wonky. There we go. And that is how you take your vertex form and transform a table of values.